like I said, while we were doing dips and stretches, flips, when you have a combination of those, the more complicated that it is, the easier it might be used mapping notation, rather than to try and keep track of doing everything in your head and doing separate points.
Like there's 3 transformations going on here. Okay? There's one here, there's one here, and there's one here.
So trying to keep track of that, I mean, it's possible, okay? But it might be easy to make a mistake.
So what I did is I found 4 reference points
On the original function, and then we're going to use mapping notation to find the 4 image points on the new function.
Don't get thrown by this.
How would you write that as a number in front of the x over 2? What's another way to write that? What number goes in front of the x? We just don't write it. 1.
So this is the same as a half x.
Okay.
This is the same as a half x. Okay, so we need to come up with a formula
For the new image points.
So let's take it from left to right. What do we got here? Vertical. Really?
Vertical. Feel free to speak clearly. Stretch. Okay. Does that affect the x or y vertical?
And if it's a stretch, it's multiplication. So we know we're going to have to multiply the y's by 2. This. Horizontal stretch by a factor of 2. So horizontal affects the x, which means every x must get multiplied by 2. And this one? Sorry? I can't. You guys are speaking over each other. Okay. So it's a vertical shift. Down 1.
And now calculate each new point. Graph.
Or plot them and then graph. So we get -6, -1. We get 0, 5, 4, 5, 6, 7.
Yes, yes, yes.
So -6, -1 is there. 0, 5 is up here. 4, 5 is over here. And the last point is there. Let's get this.
Which appears to make sense because if you look at the new one, certainly it seems to be horizontally stretched and vertically stretched. Might be hard to see the shift, but it still does take place. Okay. I'm going to get you to do this one, but look at the function. Is there anything that needs to be done? You have to factor because there's horizontal shift going on,
But that means there should be parentheses between the negative and the x. So we have to factor out negative or -1. And when you do that, you get x plus 3. So that's what it should look like.
See if you can do it. Hopefully you're able to recognize there's two transformations that are taking place. This might be one that maybe you could do without mapping notation. But if you're unsure, stick with the mapping notation. What do you think, they got a formula? That they want to share?
What's happening here? So it's a flip, horizontal flip,
Which means it affects the x's.
so there should be a negative in front of the x. This means
3 left, so we're losing 3 from each x. -3.
these don't change.
There's nothing vertical happening.
So my points were -3, comma 1, -1, comma -3, and 2, 2. So -3 becomes 3, -3 becomes 0, comma no change for the 1. -1 becomes 1, -3 is -2. No change to the 1. This just becomes -2 minus 3, -5. No change to the 1. So this becomes 0, 1. And this becomes -2, -3. And I'm going to connect as I go so I don't get mixed up. -5, comma 2. Like so. And then hopefully you can see that the arrow will have to go that way. You could have used another reference point here and added another one on just to make sure.
But that seems to make sense. I mean, a horizontal flip, so it's going the other way. It's going to the left. And it seems the shift took place as well, so I think we're good. This one.
Well, you may notice something about this one that's a little weird. It's got absolute value.
Okay. You can do that using mapping notation. Notice the absolute value is outside the function, right? So what, do you think it's going to affect the x or y? If it's outside the function, y's. And what's it going to do? It's not going to do anything to positive numbers, but it's going to change every negative one to a positive.
So absolute value affects y's.
So when we do our mapping notation, we got to keep that in mind. Okay.
Let's see our reference points here. I always do from left to right. You can do it from right to left. So I've got -1, 0. I've got 1, -3. I've got 2, 0.
Anything happening inside the function? Nope.
Which means no change here. That means everything's going to affect the y's. And what's going to affect the y's? Well, we're going to take the absolute value of them. And then we're going to multiply them each by 2. And then we're going to add 1. So I'm going to get -1. 0 times 2 is still 0, plus 1 is 1. X stays the same. -3 becomes +3, then times 2 is 6, plus 1 is 7. Two doesn't change. 0 times 2 is 0, plus 1 is 1. So we're going to have -1, 1. 1, 7. Two, 1. And, well, you know what? You got a little bit of a problem. Because what's happening over here? Maybe I should do an extra point. So let's do -3, 3. So if you're unsure what's happening, do an extra point. So this is going to become -3. 2 times 3 is 6, plus 1 is 7. So that's -3, 7. We draw that. Because remember, this has got the arrow in, right? Just like that. Which makes sense, because if you think about it, if you take the absolute value first, this is going to flip above. Okay, this is going to flip above. So it's going to, so it's going to take this shape. And then I'm going to stretch it and shift it up 1. Okay. So be a little careful with absolute value. Any questions about those? Because now we're going to go backwards. Going backwards can get a little challenging, especially when you have multiple transformations going on. Okay. But what I would suggest you do, and it basically summarizes that in the gray box at the top, is get your stretches first, get your flips, and then we're going to have to do a little math to figure out if there's any shifts. Okay? So, for example, remember, to write the equation, we need to know A, B, H, and K. Now, A and B are the stretches and flips. So I'm going to establish these first, and then use a little math to figure out if there's any of these. Okay. Here's the original. Here's the new one. Does it look like it flipped? And if so, which way? Yeah, like if you look, a lot of times looking at the endpoints of the original function will help. So like these are like this, so it's almost like a ladle, but yet it's facing that way now. So that suggests to us that it is a horizontal flip, which means this is going to be negative.
Did it stretch? Certainly seems like it. Vertically or horizontally? Vertically, right? Because, and the way to do this is, well, what's the distance from the bottom of the function to the top in the original? It's 1, 2, 3, 4, 5, 6. What's the distance from the bottom to the top into this transformed one? 3. Which means it's stretched. Remember, what do I multiply to get from 6 to 3? A half. And remember, vertical doesn't flip. So A is a half. And I've taken care of 4 of the transformations now. Okay? Now, if there's any shifts, here's what I would do. I'm going to pick a point. Don't pick one that's on the axis. Like, don't pick any of these. Usually pick one on the end. So I'm going to pick this point. Okay. I know that I'm going to flip it horizontally and stretch it by a half, correct? So if I flip it horizontally, doesn't it end up over here? And if I stretch it by a half, well, now I got to look at the y value 4, it goes to 2, right? So after the 2 I've established, it's here, but it needs to be here. And remember, the only thing I have left are shifts. So how do I have to shift from here? I know it's to get to here. How do I shift?
Down 1.
Down 1, which means K or H? -1. So I'm down 1. And then I've still got to go. Wait a minute. No, what am I doing? I'm confusing you. I apologize. I'm here, but sorry, it's this graph we're dealing with. Sorry, there, right? Because because I'm making this graph into this graph. So what I'm doing is I'm flipping it and putting it down, so it goes there, which means on the new graph it's here. Sorry, my mistake. I don't know why it keeps putting these things. That's what it is. Okay, so we're here. So there's not. Okay, so I'm here. How do I get to here?
H is greater than 2.
Yeah, H is, sorry, -2. Aren't I moving to the right? So H is +2.
In the equation, it would be,
Sorry?
in the equation, it would be greater.
Yes. So that means there's nothing for K. You see the transformation equation above, so it's going to be y equals, and then A, which is a half, and then F, open a set of parentheses, and then there's a value for B, so negative, and then open another set of parentheses, and then X minus H, so X minus 2, close and close, don't write plus K. There's nothing for K. K is 0. Okay? I
Okay, let's try the last one.
What do you see from here to here? Remember, we're thinking stretches and flips. Flip, vertical or horizontal? Like the label is sort of right side up here, but now it's upside down, so it must have flipped this way.
So it must be a vertical flip, which means what letter is that effect? If it's a vertical flip, A, and A is edge.
Stretch.
Well, remember, the original height was 6. This height is still 6, so it didn't stretch vertically. But it sure looked like it stretched horizontally. What's the distance from the left to the right? It's that. So it's 1, 2, 3, 4, 5, 6. What's the distance of the new one? 3.
What do I multiply to get from 6 to 3? A half, but what goes in the equation? 2. Excellent. And we've accounted for 4 of them now. We just got to do the shifts. So let's go back up to this point. And I'll make sure I do it right. Okay. Or use a different color, but I'm going to use the same point.
So it's been flipped vertically. So it's 4 above the x-axis, so it's going to be 4 below. So it flips down there. And remember, even though it's the horizontal, or sorry, the value of b is 2 in the equation, the horizontal stretch is still a half. So it goes from here, x is 4, to x is a half. So it goes here after the stretch. Now let's transfer that point down here. So that's 2, and then it looks like I'm going 4 down here. So that's where it is, right? Or should it be? Here. Which means I have to shift what? Up 3. To get to its image point. So K is 3. There's nothing for H. There's no horizontal shift going on. And now use the transformation equation to write the transform function. So y equals a negative f, open up a set of parentheses. Now, I mean, there's no horizontal shift, so you don't need double parentheses. If you put it like this, that's still right. That's still right. Okay. Or if you just take out these parentheses, that's correct as well. How do I finish it? Plus 3. So you can see that's a little bit more challenging. Okay. But if you account for the stretches and flips first, pick a reference point, see it where it ends up after the stretches and flips, and then find on the new graph where it should be, and then you'll be able to find your shifts. Okay. Okay.